Okay, so these first three examples are kind of to do with kinematics, but are not involving any acceleration. So the first one's really just a velocity example, but really it's just kind of recapping some vector stuff. So part A wants the average velocity and the average speed from C to B, so that's part of the journey. So I'm just going to work out what that journey is from C to B. So I need the vector, and all these vectors, I'm just going to write them down first actually. Our position vector, it says, so OA, which is 3 minus 1. OB, 1, 5. And OC, which is negative 2, 1. Okay, so again, writing them in that way I will always do, and just gives you that advantage of ease of vector questions. So CB is going to be C to O plus O to B. And remember, C to O is just this vector here, OC, if I move it over, but changing the sign, so positive 2, negative 1. Back over here now, and adding on 1, 5. CB. Notation is important. And that's going to give us 3, 4. Okay, so that is the, I suppose that's the displacement vector. If you want to be technical about it. And then we just need the velocity. So that part C to B is the 3 seconds. Okay, so that is a distance or displacement. So we can divide that by the time to get the velocity. So we can do 3, 4, effectively 1/3 of that for 3 seconds. Okay, so let's make a note of that there. That's basically dividing by 3. Okay, so that is going to give me 1, and I'll put 4/3 on the bottom. Okay, I quite often go on mechanics about significant figures and decimal answers, but I think for 4/3 in this case that's okay. So that's meters per second. That is the velocity, a vector, and then our speed needs to be a number. So for the speed, we need to use, think about the magnitude if you will, so we're going to use Pythagoras. So 1 plus 4/3 squared, square rooted, and put my calculator up. And that is going to be 1.67 meters per second. Okay, so that is part A. Fairly straightforward. Again, just a recap of vectors really. So I'll put part A here. I've got people for that quite often. Okay, part B is the final displacement from A. Okay, so we go from A to C and then to B. So the final displacement really is just going to be AB. Okay, at this point, if you then look ahead to part C, which is about velocity. Sorry, my computer's just locked, so I've lost the example. Again, we only need the displacement, we don't need the distance, so we don't need the A to C, C to B at this point. Okay, so A to B is going to be AO plus OB. So A to B is going to be negative 3, 1 plus 1, 5. That's going to be negative 2 and 6. Okay. Which is our answer for part B. Just checking with the book, given my computer's locked. And then part C is going to be the average velocity. So we need to know the total time now. So it's like distance, speed and time basically from GCSE, but with just adding in vectors. So we've got 3 and 5, so that's 8 seconds. So a similar process to part A really, the end of that, but using our new vector here and our new time. So it's going to be 1/8 of negative 2, 6. I think I just find it easier to say that fraction is what we're going to do. And that again, it's not a very good arrow. Can't see it though. It's dividing by 8. And then the question asks for a velocity again, so our answer is going to be a vector. So this time I'm going to do decimals, a bit nicer than in third. So 1/8 of -2 is a quarter minus a quarter, minus 0.25. And 1/8 of 6 is 3/4, so 0.75. And then meters per second. Okay, so quite straightforward for that one. Part D wants the average speed of the whole journey. Yep. Now, I've got to be very careful here. Okay, we can't just do A to B. Okay. If you think about being A here, and then B being over here, and maybe C being here, we've obviously gone from A to C, and then C to B, I believe. Yeah, that's right. Then the distance that we're actually travelling, so for speed we're looking at distance, that distance and this displacement are not going to be equivalent, so we're going to have to break the journey down a little bit. So we have to do the journey as it actually occurred for this question. So we're going to need A to C, and then we're going to need C to B. All right, I think we've already done C to B. So C to B we know is 3, 4. We've got that from part A. So we're not going to do that again. I've got my camera now, I know what's going on. So AC is going to be AO plus underneath AO plus O to C. I don't think we've done that already. Just have a quick look through. Now I've got A to O there. That's -3, 1. And O to C is -2, 1. So that's going to be -5, 2. Okay. So these are the two velocity displacement vectors rather. Because this is about distance though, we need to get the distances of those two first. Okay. So for C to B, I'm going to put this modular sign. Sometimes, I think we've talked about this before with vectors, if you just put the letters CB without the arrow, that's also the distance. But I prefer the vector notation and then the modular sign. I think it's clearer what you're doing. So the distance from C to B, you might be able to work this distance out of your head. It's the Pythagorean triple. It's going to be 5 meters, or root 25 if you prefer. This one I can't do in my head. So this is A to C. So we'll do my calculator, although I'm going to leave it as square root for possibly. My calculator behaves. So 5.385. Okay, so our total distance is going to be the addition of those. Got into a bit of a mess here with my working. So 5 plus that, so 10 point, let's say 10.4 meters. I think in fact that's what the book goes with as well. Okay, and then for our speed we just need to divide that by the time. Okay, so for the average speed, we're going to be doing 10.4, obviously 10.38 would be more accurate, I suppose. We should have done that. We're going to get 1.29 now, round up, so 1.30 meters per second. I've actually used the exact answer there. Okay, so that's just an example of applying vectors to what is effectively distance, speed and time.